So I told you we're going to do things a little out of order. So we did lesson 1, which was functions and invertible functions. And we did lesson 4, which was rewriting radical expressions into fractional exponents or rational exponents. And if you had rational exponents, being able to write those into radical expressions. Now we're going to do lesson 2, which is graphing radical functions and inverses, finding inverses. So we're going to start with, and there's a warm-up couple questions on invertible functions. Take a look at those. If you have any questions, let me know. I'm going to drop right down to what's called graphing the squared function. So the squared function is literally x squared. And we have this table of values. For every x value, we squared it, and we've got this wonderful table. We're going to graph it. Okay, so let's find a pretty little color here, and I'm going to zoom in so I can really look at this. So let's see, -3, +9, -2, +4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. All right, so there's my basic curve. It's the parabola that we've been doing math 2, basically a bunch of it. First semester we did a lot of work with it as well. So let's answer a few questions about the graph. Is it a function? Yes, it would absolutely pass the vertical line test. Is it an invertible function? No, it would fail the horizontal line test miserably. The domain of the squared function, this is all your possible x values. Well, every x value is possible. Range are your possible y values. Now, in this case, the lowest y value we can work with is 0, and we go to infinity. So basically, no matter what x you put in, it's all going to be positive values except for 0 itself, so that's your lowest value. X-intercept, there is 1 at 0, 0, the origin. Y-intercept is the same 0, 0. All right, so that is the squared function. Now, what we're going to start doing is what's called finding the inverse. Now, the inverse of a function, you are going to invert the x and the y values, the variables, and re-solve the equation for x. I'm sorry, no, solve for y. I lied to you, sorry. Okay, so step 1, replace x and y. Okay, so your y is going to change into an x, your x is going to change into a y. Step 2, solve for y. Had to make sure I said it right this time. Didn't say it right the first time. So in this case, we've got y squared. So to get y by itself, we need to get rid of this squared function. The opposite of squaring something is to take the square root. So y equals, now because we put the square root in the problem, and I'm stressing that the square root was not there originally, we have to add a plus minus in front of that root, in front of that radical. So that is the inverse of the squared function. Okay, so y equals plus or minus the square root of x. That's the function. Well, that's the inverse. I'm not sure if it's a function. In fact, I'm pretty sure it's not, considering we said it wasn't invertible. So now it says, use the information from the squared function to fill in the table of values and graph the inverse. Now, this is where it becomes this part of this step 1, replace x with y and y with x. So in that ordered pair, and I'm going to see if I can kind of pinch in so I can go up here. Where x was -3, y was 9, reverse these two. So make the x value be y, make the y value be x. So x is 9, y is -3. X is 4, y is -2, x is 1, y is -1. 0, 0 is pretty easy to invert. 1, 1, 4, 2, and 3, 9. Okay, so let's graph it. Okay, so we've got positive 9, 1, 2, negative 3, positive 4, negative 2, positive 1, negative 1, 0, 0. Whoops, I have an extra little point there. So 1, 1, let's see, 4, 2, and I wrote that wrong. I realized the last one I wrote is wrong. It should be 9, 3, not 3, 9. I'm looking going, wait a minute, something's wrong with my curve. All right, so 9 and then 3. Yes, it actually helps to fully replace the x and the y values. So we've got the curve that looks like this. Now you'll notice I said curve and not function because first question I'm going to ask is it a function? The answer is no. This fails the vertical line test miserably. Domain are your possible x values. So domain here is going to be, well, the lowest x is 0 and we go to infinity. Range, this graph is going to keep expanding up and down. So your range here is going to be negative infinity to infinity. X-intercept, still 0, 0. Y-intercept is still 0, 0. Couple of things that I want you to maybe notice. The domain of the original function is the range of the inverse. The range of the inverse is the domain of the function. Okay, so those are all important pieces to know. Now, what we're going to do is we're going to move on to the next part here, and we are going to restrict the squared function so we can graph the invertible squared function. Okay, so squared function, we're still dealing with y is equal to x squared, but we're going to restrict it to say that x can only be greater than or equal to 0. So if you look at our ordered pairs here, it's much smaller. We're only dealing with positive 0 and then all of your positive x's. So if I graph this, we've got 0, 0, 1, 1, 2, 4, and 3, 9. So the graph is going to look familiar, but it is only half of the curve that we had originally because x is only allowed to be greater than or equal to 0. So none of these values to the left here are going to have any impact on this graph. There are no values there, okay? So based off of our pretty graph here, is this a function? Yes, it will absolutely pass the vertical line test. Is it an invertible function? It is now. Because when we draw that horizontal line, we're only ever going to hit the graph once because we've eliminated the other half of this curve. Okay? Domain, we've actually already said what the domain is. We've restricted the x values to be greater than or equal to 0. So domain is going to be from 0 to infinity. Range, well, our lowest possible y value is 0, and we're going to go to infinity. So range is 0 to infinity. X-intercept, 0, 0, and y-intercept is 0, 0. Now we're going to find the inverse of the restricted squared function. So step 1, replace x and y. Or actually, instead of replace, let me reverse that. Switch x and y. So where we have a y, we're going to replace it with x. Where we have an x, we're going to replace it with y. And that's actually going to apply to this piece of it as well. So y is greater than or equal to 0. All right, so we're going to do the same process we did the last time. So we're going to solve for y, which is step 2. So step 2, solve for y. Take the square root of both sides. So square root of x is equal to y. Now, I am not going to put the plus minus in front of the x squared. The reason y can only be 0 or positive. If I put a negative in front of this square root, then I'd be saying that y could be a negative value, which is not a true statement. All right, so be careful with that. So our new function is y equals just square root of x. And we're going to use this table of values and we're going to invert them. So x and y are going to switch places. Now 0, 0, and 1, 1 don't really look like much change, but the other two will. So we're going to have 4, 2 and 9, 3. So let's graph it. 0, 0, 1, 1, 4, 2, 9. Nope, I didn't write that at 3. There's the 3. It's like, wait a minute, that doesn't look right. And it looks like that. All right. So let's take a look at this function. Yes, because if I draw a vertical line, it's only ever going to hit the curve once. Domain is from your possible x values from 0 to infinity. Range are your possible y values. That's going to be from 0 to infinity as well. X-intercept 0, 0, and y-intercept 0, 0. All right, I'm going to go ahead and cut the video here. There's a lot of information in this video. If you have questions or concerns, please ask. Okay, the next video I'll pick up with the cubic function and finding its inverse. And we'll see if there's any changes that we need to make to a cubic function to make it invertible, like we had to restrict the domain for the squaring function. Any questions, send them to me in Canvas, send me messages, or join those Zooms, and we can talk about